Laws of exponents. Operations on real numbers in exponential form follow a set of rules which are called laws of exponents. The first law is called the law of zero component. Laws of components. In this, the first law is, like I already said, is called the law of zero component. It means anything power 0 will always be equal to 1. So if 2 power 0, that is equal to 1. If x is power 0, that is equal to 1, or x over y, which is a fraction, if this is raised to power 0, that is equal to 1. Means anything raised to power 0 will always be equal to 1. Number 2. The second law is for mn belonging to I. Means m and n are any two integers. Then anything power m, x raised to power n is equal to x power m plus n. What really it means is that if the base is same, like x here is the base, x here is the base, if the base is same, the exponents will always be added. If base is same, exponents are added. Now, if we take a look on the example here, this is, we can give an example of 2 raised to power 3 times 2 raised to power 4. If this is the case, then we know that 2 raised to power 3, if we write this as product of repeated numbers, this would be 2 times 2 times 2, and 2 power 4 will mean 2 times, so this is 2 power 3, this is 2 power 4, which means 2 times 2 times 2 times 2. 2 power 4 means that 2 is repeated 4 times, and 2 power 3 means 2 is repeated 3 times. If we write the overall product of 2, if the base is same, means that on both sides the base is 2. 2 times 2 times 2 times 2 times 2 times 2 times 2. So overall 2 is being multiplied 7 times. This is equal to 2 power 7. And is it not equal to 2 power 3 plus 4? This 7 we can get directly by simply adding the exponents. If we do another example, probably this example would be easier to follow, in which we say minus 3 power 4 time minus 3 power minus 3. Evaluate. So if we were to evaluate, if this is this, then evaluate. So this, what would be the expression? Obviously, using the first law of exponent, we have learned that if the base is same, then exponents can be added. And here in both cases the base is minus 3. So minus 3 power 4 into minus 3 power minus 3. We have to make sure that the base is same, this which is minus 3 in both cases. Now we can add the exponents, and this would be minus 3 power. If we add 4 plus the number negative 3, and this would mean minus 3 power 1, which we don't write. If 1 is the exponent, it's obvious we don't write, so the answer would be minus 3. This is illustration for the first law of exponent. Now the second law, law number 2. And in second law, this is for two real numbers, x and y. If x times y has power of m, it means this power will be distributed both for x and for y. So this will mean x power m times y power m. If this was true, then it means that if 2 times 5 overall has power 7, this will mean 2 power 7 separately and 5 power 7 separately. Let's do an example, and the example here would be, if we have 3 times 7 power 5, what it really means is that we're going to multiply 3 times 7, again 3 times 7, then again 3 times 7, again 3 times 7, and again 3 times 7. So because what is base? Base is 3 times 7, and the base has to be multiplied with itself. How many times? 5 times, equal to the number of exponent. Whatever is the exponent here is 5, so we multiply it 5 times. So doesn't it mean that 3 is multiplying with 3 5 times? So 1, 2, 3, 4, 5. So 3 is multiplying with itself 5 times, and 7 is multiplying with it 5 times. So this would be 3 power 5 into 7 power 5. This is exactly what our law is saying, that if you have two numbers in the base and then they have one exponent m, then the exponent will get distributed over both of the numbers. That's why we can say that if a into b has power n, this means a power n to b power n. So this is second law, and now we are going to take a look on the third law, law number 3. And this law suggests that x power m whole power n is equal to x power m times n. What it means is that if you have 2 power 3 and then this whole thing 2 power 3 is acting as a base, and there is another exponent which is 4, then this is equal to 2 power 3 times 4. So this is the third law. But here there is a very important point which we need to remember, that if there was no bracket, like if this was not the bracket here, if we were to write 2 power 3 without bracket, if we were to write 3 then power 4, then that will be entirely a different scenario. In the first scenario, what is the base? The base is 2 power 3. So here base is 2 power 3, and what is exponent? That is equal to 4. But in this case, 3 power 4 is the entire exponent and 2 is the base. So 3 power 4, if we were to simplify, 3 power 4 itself is a big number. So this is not equal to 2 power 3 power 4. So remember this difference, that 2 power 3 is not same as 2 power 3, because in this case, what is 2 power 3 equal to, that is 2 power 2 times 2 times 2, like 2 power 3 means that 2 is multiplying with itself 3 times, and this would be equal to 2 power 8. But if we were to write 2 power 2 and then power 3, this would mean 2 power 2 times 3, and this would mean 2 power 6. So clearly 1 and 2 are showing that 2 power 3 whole raised to power 3 is not equal to 2 raised to power 2 power 3. So this was the third law, and if we want to prove it, let's see that we have x power 3 power 4. If this is the case, then how can we write here, what is the base? The base is x power 3, and what is the exponent? That is 4. So x power 3 times x power 3 times x power 3 times x power 3. Now if we apply the first law, the powers must be added, because now each has base as x. So this would be x power 3 plus 3 plus 3 plus 3, and this would mean x power 12, which is same as if we were multiplying 3 with 4. So this bracket makes a big difference, and therefore we conclude that a power m power n, by separating two powers with brackets, means that two powers can be multiplied m times n. If there was no bracket, then this is not the law which will govern that operation. And this was law number 3. Now we are going to take a look on law number 4. Law number 4, and the law number 4 is x power m over x power n, and this is equal to x power m minus n if m is greater than n. Means that if this exponent is greater and this n exponent is smaller, then the exponent in the denominator can be subtracted from the exponent in the numerator. The example could be 2 power 5 over 2 power 3. Now the base is again the pivotal in this case. If the base is same only, then we can do the operation. Remember that here base is x in both cases. So this way we can say 2 power 5 minus 3. And we always want to keep the exponent positive. So if this was a different scenario, if m is less than n, it means that the exponent in the denominator is bigger. Then same thing we can say x power m over x power n is equal to 1 over x power n minus m. And here in this case we can give a example that 7 power 3 over 7 power 5 is equal to, now which exponent is bigger? The bigger exponent is in the denominator. Therefore, we are going to subtract the smaller exponent from the bigger exponent. So this would be 1 over 7 power 5 minus 3. So this is how we simplify the fractions in which the numerator and denominator have the same base but different exponents. However, if m and n were equal, if m is equal to n, then x power m over x power n is equal to, now because m and n are equal, so x power m minus n is in fact equal to x power n minus n, because m and n are same, which gives us x power 0, and the law of zero exponent suggests that anything power 0 is always equal to 1. This was law number 4, and now we have law number 5. Law number 5, and law number 5 suggests that x over y with power m is equal to x power m. The power is distributed in the numerator and the denominator, so y power m. So we can separate the powers of the numerator and the denominator. And the good example would be if it is 5 over 7 power 3, we can simply write 5 power 3 over 7 power 3. This is how we can write. Let's try to prove this. And if, let's say that x over y has power 3, what really it means is x over y. What is the base? X over y. So this is x over y again, this is x over y again, and this means in the numerator x is multiplying 3 times, and in the denominator y is multiplying 3 times. This means x power 3 over y power 3. So that's how it works. So it means that if a over b power n means that it is equal to a power n, b power n. Now let's do few questions to apply these laws in questions. Let's take a look on this question. Simplify 27 a power 3 b power 2 over 8 c square d cube whole power 3. Now, as we have learned that if there is a 1 power outside the bracket, then everything inside the bracket gets the same power. So this means, so if we were to solve this one, 27 a cube b square over 8 c square d cube power 3, this, let's distribute this power to each one of the number in the base. The whole 27 a cube b square divided by 8c squared d cube is the base. So let's divide the exponent 3 to every member of the base. So this is 27 power 3, then a cube power 3, then b squared power 3, and then 8 power 3, then c squared gets his share, and d cube also has power 3. Now further we are going to take a look which one of these can be simplified. Now here we have 27 power 3. Whenever there is a number with an exponent, try to make its base a prime number. And I already illustrated this concept. Let's first divide 27 into its prime factors. And the way we do prime factors, we always write prime numbers here on the top, 2, 3, 5, 7, first few prime numbers, and then take a look on the number. If number is even, we start with 2, otherwise we skip 2 and then we go to 3 and see if 3 will divide the number. So 3 in this case will divide. 3 9 times is 27. 9 is again divisible by 3, so we divide it again. So this is 3 one time. It means that 27 can be written as 3 times 3 times 3, which means that 3 power 3, because that's the exponential form. If we add the exponents, that is equal to 3 is multiplying 3 times, so the exponent is 3 as well. And same thing we do with 8 in the denominator. The 8, if we want to break it into its prime factor, we start with 2 because 8 is prime. 2 4 times 4, 2 again, 2 1. So 8 is again equal to 2 times 2 times 2, which is equal to 2 power 3. So let's change 27 with the corresponding equivalent number. That's 3 power 3 and whole power 3 again, and then a power 3 power 3, b squared power 3, and then a 8. Instead of 8 we're going to write 2 power 3 and then power 3, and then c squared power 3 into d cube power 3. Now if you remember the law of exponent, which suggests that x or x power m power n is equal to x power m times n. Every base has a bracket and we can comfortably multiply the powers. 3 times 3 is 9 into a, 3 times 3 is 9, and b power 6, and 2 power 3 times 3 is 9, c power 6, d power 9. Now in the denominator we should see if there are same bases for different numbers. No, in the numerator their base is 3, then a, then b, and in the denominator it's 2 and then c and d. None of the base is same, so this is the simplest it can get. Therefore we leave it here, and now we move forward and we do another couple of questions. So let's take a look on this question here. If we have is 16, or let's say 18, m 6, n 9 over 6, m 4, n 4, and whole raised power 2. Just like before, we should break any number which can be broken into its prime factor. We got 18, but instead of breaking that, we can simply divide 18 by 6, which gives us 3, and that will be in the numerator. 3 m6 n 9 over m4 n 4 power 2. We can either apply the law before we take that 2 into account, and if we apply the law within brackets first, then this would be m power 6 minus the similar base. Here m is the base, in the denominator there is m is the base. So if the bases are same, then see where is the bigger exponent. The bigger exponent is 6, therefore we're gonna get 4 to be subtracted from 6, so 6 minus 4. And similarly, now the base n and n is same, we therefore are going to take a look on the exponent. The bigger exponent is in the numerator, therefore we're gonna subtract 4 from 9, 9 minus 4, and the whole power 2 is still outside. This means 3 into m power 2 and n power 5 power 2. This is equal to 3 power. Now this power 2 will be distributed to all three numbers inside the bracket. So this will be 3 power 2 into m square power 2 into n 5 power 2. This would be 3 power 2 would be 3 times 3, that is 9. M power 2 times 2 is 4 into n 5 times 2 is 10. This is the simplest form it can get. Anything power 0, that is always equal to 1. So if 0 over, now the last question we're going to do is if it is 0 over y power n, anything when 0 is such a special real number that 0 divided by anything is equal to 0. So 0 over y is in fact equal to 0, and doesn't matter 0 has whatever power, the answer is always equal to 0.